Welcome and thank you for joining. We'll continue with the mock exam full solutions. Let's get started with question 1. Solve algebraically the equation 6x cubed minus 17x squared plus 11x minus 2 equals 0. This is a polynomial equation of degree 3. Remember, the way we determine the degree is by inspecting the powers of the variable x, and the highest power will make the degree of the entire polynomial. Now, to solve a polynomial equation algebraically, we have used what we call the factoring technique. Since we have a third-degree polynomial equation, that means that the maximum number of factors that we can break this equation into is 3. It is the same as the power of the polynomial equation. Now, since again this is a third-degree polynomial equation, it means that each factor will be in linear form. And the linear forms we're looking at are ax minus b or x minus b. So it could be a combination of the two types of linear equations, which means with a slope of 1 or with a slope of different than 1. Now, how do we search for these factors? So how do we figure out what these coefficients in here are in order to solve the equation? Now, for this, we use what we call the remainder and factor theorem. So a quick review of remainder theorem, we say that if we have a polynomial px and divided by a binomial of the form x minus b, we will say that the value of the remainder would be equal to the value of the polynomial at b. Similarly, we've said that if a polynomial px is divided by a binomial linear expression of the form ax minus b, then the remainder would be equal to the value of the polynomial at b over a. Now remember that for this binomial to be a factor of the polynomial, we need the remainder to be equal to 0. And here is a quick example to refresh your memory. For example, if we have the number 6 and we divide it by 2, then the answer will be 3 and the remainder will be equal to 0. So when the remainder is 0, we say that the number 2, so the divisor, is a factor of number 6. And number 6 can be written as 2 times 3. On the other hand, though, if we have a number such as number 7 divided by 2, we get the answer 3 and the remainder will be equal to 1. So in this case, we say that we cannot write number 7 as a product of 2 and 3, which means that number 2 cannot be a factor of 7. And that is because the remainder equals 1. So going back to the remainder theorem, then we're going to say that if we want to figure out the values of b that will make our factors in here, or the values of b over a that will make the factors in this polynomial, we have to search for those b values or those b over a values that will give a remainder of 0. So let's start the journey of figuring out the values of b and b over a. So I want you to think, where do we get the values of b in the polynomial? So if you look at the values of b, they are the constant terms because they do not have a variable attached to it. And if you were to expand this factored form to make it into standard form, like the same format the equation is given in, that means that these b values multiplied together will give the constant term at the very end. And this is the reason why we say that to figure out the values of b, we always look into the constant term of the equation. So we're going to say that the values of b must be factors of the constant term because the constant term is made by the product of these b values. So therefore, we're going to say that since the constant term is negative 2, then the b values might be plus or minus 1 or plus minus 2. On the other hand, if we're looking for factors of the form ax minus b, then we're going to say that we need to take care of the coefficient a. Now, where does the coefficient a come from? So the coefficient a is going to come from the product of the coefficients of x in every factor. So that means that this coefficient of the leading term, because the leading term here will come from x times x times x power of 3, So the coefficient of the leading term can help us figure out the values of A, the possible values of A. So we'll say that the possible values of A are the factors of 6, which are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So to figure out the values of B over A, then we are going to say that we need to consider the list of the numbers that B and A can have. So the values that B and A can have. So the way I like to do this is by working with one number at a time. So I start with the value of B plus minus 1, and then I divide it with every possible value of A. Remember, plus minus 1 divided by plus minus 1 is plus minus 1. Plus minus 1 divided by plus minus 2 is plus minus half. Plus minus 1 divided by plus minus 3 is plus minus 1/3. And plus minus 1 divided by plus minus 6 is plus minus 1 over 6. Now that I've exhausted all the possible combinations of B with the possible A values, then I am going to use the next factors of B. Plus minus 2 divided by plus minus 1 is plus minus 2. Plus minus 2 divided by plus minus 2 is plus minus 1, but we've already listed plus minus 1, so we don't have to list it twice. So plus minus 2 divided by plus minus 3 is plus minus 2/3. And plus minus 2 divided by plus minus 6 is plus minus 1/3. Plus minus 1/3 is a number that we have already listed. Therefore, we're going to say that we don't have to list it twice. So these are all the possible values of B over A. So we have to search now for the values of B over A that will give the polynomial a value of 0. In this way, then, we can use these B and A values to form the factors. Now, I want to draw your attention at the leading coefficient 6 in here. So number 6 can be broken down into the factors. I'm going to write them down here in green. Into factors 6, 1, and 1, or 3, 2, and 1. And obviously you can alter them. The order in multiplication doesn't really matter. So what this tells me is that yes, one of the factors has to be, at least one of the factors has to be in the form ax minus b. So let's say 6x minus some b value, or 3x minus some b value, or 2x minus some b value. But it doesn't matter how we factor or what the factors will end up being. One of the factors will be in the form x minus b, which simplifies my work. The reason why is because it is easier to figure out the b values when we have a coefficient of a equals 1. So I'm going to play smart this time, and I'm going to use only the b values plus minus 1 and plus minus 2. So I'm going to use the values that do not have a different than 1. So I'm going to search for my factors by finding the value of the polynomial at 1 first. So that will be 6 minus 17 plus 11 minus 2. So as you can see in here, we have a negative 11 plus 11, 0 minus 2, negative 2. So that would be negative 2, which is different than 0. And that tells us that x minus 1 is not a factor. So I'll search for the next factor or possible factor by substituting the value of x by negative 1. So if I do this, that means that we have 6 times negative 1 to the power of 3. That would be equal to negative 6. And then negative 17 times negative 1 squared is negative 17. And then 11 times negative 1, that's negative 11. And minus 2. And without really having to evaluate this, you can tell that you're going to end up with some negative number which is different than 0. So therefore, we're going to say that x minus negative 1, or as we call it, x plus 1, also is not a factor. So moving on to the next possible values of b, we have a plus and minus 2. So the value of the polynomial at 2 would be equal to 6, 2 to the power of 3, minus 17, 2 to the power of 2, plus 11 times 2 minus 2. So during the exam, you let the calculator do the work in this case because it is faster, and saving time when you're writing an exam or any evaluation is very, very important for so many reasons. So we're going to talk about it when to more extent when we talk about the exam or test taking strategies. So what we have in here is 6 times 8 minus 17 times 4 plus 11 times 2 minus 2 equals 0. And the calculator will give you a value of 0, which tells you that x minus positive 2 is a factor. So we have a winner here. So once you have figured out the first factor, everything becomes a lot easier. So we will divide the polynomial by x minus 2. And I would prefer to use synthetic division because it's faster. And synthetic division is possible when we have a divisor that is in linear form or first degree. So for synthetic division, remember that we use the coefficients of the polynomial expression or the coefficients in the equation. So in our case, 6, negative 17, 11, and negative 2. Number 2, the magic number 2, will be sitting right next to number 6. We bring 6 down and multiply number 6 by 2. We get number 12 here. Add negative 5. 2 times negative 5 is negative 10. Add again. 11 plus negative 10 is 1. And 1 times 2 is positive 2. Add negative 2 to positive 2 and you obtain 0. So that means that the remainder is going to be equal to 0 as promised. So therefore, we're going to say that the polynomial in factored form, the polynomial equation in factored form will be x minus 2. That's the first factor we discovered. And the other factor is obtained by these coefficients. So we have 6x squared minus 5x plus 1. So we'll write that down. So 6x squared minus 5x plus 1 equals 0. Now, solving the polynomial becomes a bit easier now at this point because we already have one of the factors and the other one is in quadratic form. And we've learned how to factor quadratic expressions in grade 10. And you can use the knowledge, so your skills from grade 10 to solve the quadratic equation by factoring. And here we go. And if you, for example, are having a hard time trying to think out the coefficients, you can always use a quadratic formula so to find the zeros of this particular expression, so particular factor. So I will be using factoring form in here or factoring technique. So the constant term is plus 1, but the middle term is negative, which tells me that the constants in each factor must have been both negative. So negative 1 times negative 1 will give a positive 1, and it will guarantee or assure that we have a middle term that is negative. So now we have to think of the coefficients of the x term. And since we have a sum of negative 5, we're going to need a 3 and a 2 here to make the negative 5. Now, the equation is in completely factored form, which means that we're ready to solve. So to solve the equation, we're going to make each factor equal to 0. So x minus 2 equals 0, or 3x minus 1 equals 0, or 2x minus 1 equals 0. So this means that x can be 2, or x is 1/3, or x equals 1/2. And voila, this is the answer to this equation. So we'll continue in the next video with the rational inequality. Thank you for watching.